Okay, we're going to learn to analyze the graph of a rational function and graph it using vertical and horizontal asymptotes. Okay, so here are our two goals. To analyze the graph, we do several things, so I'll be asking you to do all these things too. First, we want to find the domain of our rational function. We do that by looking at the function here. There are no square roots, so we don't have to worry about possibly square rooting a negative, which would make something imaginary. But we do have a variable in the denominator, so we do need to worry about the denominator becoming 0. So let's find out when that happens. We say x squared minus 4 equals 0, x equals plus or minus 2. So I would say x squared equals 4, and then square root that, and then that's how I got that guy. Alright, so what that means is that my domain would actually be all x's provided that x does not equal plus or minus 2. Alright, then it asks us to write the function in lowest forms. That means that it needs to be all factors, because if we can factor something and cancel away, it changes the way our graph works. So in order to do that, I would say that f of x equals x minus 1. That can't be simplified at all, but I can factor this to x plus 2, x minus 2, since it's a difference of two squares. Now we're in the lowest terms. We don't have anything squared, and we'll be looking later on to see if we can cancel out any of our numerator and denominator factors. Then it says to find the intercepts of the graph. Alright, intercepts of the graph. The x-intercepts come from the zeros of the numerator. So x minus 1 is our numerator, so we set x minus 1 equals 0 and solve. So x equals 1 will be a 0 of our function. If I was asking you what the multiplicity is 1, because that factor and that 0 show up one time, which means we're going to cross at 1. So again, I'm analyzing the graph. I'm looking at the information of the function and saying, I can pull out a lot of info about what's happening here. Alright, so we want to test the same function for symmetry, just to get a help with the vision of what this graph should look like. If it's an even function, well then it should have symmetry about the y-axis. If it's an odd function, it should have symmetry about the origin. If it doesn't have either of those, then it's neither. But at least we'll know something about it. So I say, alright, well then what would r of negative x be? Well, that'd be negative x minus 1 over negative x squared minus 4. That becomes negative x minus 1 over x squared minus 4. So we didn't change anything, so it's neither. Okay, so it's not going to have symmetry about the y-axis, and it's definitely not going to have symmetry about the origin. Okay. Alright, so we're going to find the vertical asymptotes by finding the zeros of the denominator. Well, we already did that by finding the domain. We know that x equals 2 and negative 2. If you need to see that again, head back to the beginning of the video. But we also know then that our asymptotes are at x equals 2 and x equals negative 2. So later when we graph, we'll see at 2, negative 2, vertical dashed lines representing our asymptotes. Okay? Alright, we want to find the horizontal asymptotes, if any. You should have notes on this from the previous section, but our m is the power of our numerator, and our numerator's power is 1. So m equals 1, and the n is the power from our denominator, so that equals 2. So m is less than n, so we have a horizontal asymptote at y equals 0. So I could draw in an asymptote right along the x-axis. Y equals 0 represents that asymptote. Alright, so now we want to graph. So first things first, I'm going to draw in my asymptotes in red here. We had y equals 0 as our horizontal. Alright. Then we had x equals 2, and so I put dashed lines there, and then x equals negative 2. Okay. Okay, so we're graphing here, and now what we're doing is we're going to use our asymptotes. So I'm going to create an X and Y chart here, and create an X and Y chart. And I'm going to plug in what I would show you. This is what should look like if you were to do it in your calculator, okay? So we've got x minus 1 divided by x squared minus 4. Okay? So there you go. And now, one of the things I like to mention is that I'm always going to pick some x values that are, to the left of my vertical asymptotes, to the right of both of them, or all three of them, whatever it is, and then in between each of the vertical asymptotes. So, okay. So then I'm going to pick, I'm going to start with like negative 3, negative 1, 0, 1, and then 3, and say 4. Okay, so that gives me some values in here, some values out here, and some values out here to look at. And that should give me a decent picture, but if not, we can always enter it into our calculator. All right. Okay, so then I go into my calculator and I plot that graph, and I go to table, and I get my different values. All right, negative 3 gives me negative 0.8, negative 1 gives me 0.67, 0 gives me 0.25, 1 gives me 0, we found that with our intercepts, 3 gives me 0.4, and 4 gives me 0.25. Okay? So then I go and I plot those. Negative 3 is at negative 0.8, so we're right there. Negative 1's at 0.67, 0 is at 0.25, 1 is at 0, and 3 is at 0.4, and 4 is going to be at 0.25. And then looking at my graph, when I graph this thing, I get something that's coming down along here, hitting those points, and shooting off based on my asymptotes. Then we come down this one, hit our points, make sure you have your arrows, and then this guy here looks just like this. Okay, so as long as you have that, you have your asymptotes labeled and drawn in, you have a graph that's shaped correctly, and a few points plotted, then I'm good. That's what I want to see when you are finished. And now you've graphed your rational function. Okay. Something to note, we cross our horizontal asymptote here. And you're thinking, but an asymptote's a boundary. Sometimes. Generally, our vertical asymptotes could be called boundaries because vertical asymptotes can't be crossed. Vertical asymptotes come from the fact that this would become 0, which is an undefined number. But a horizontal asymptote, and really asymptotes in general, are patterns of what our function is doing or where our function is approaching as x approaches infinity. So as x gets bigger and bigger and bigger, our function approaches 0, which is why we say y equals 0 is our asymptote. Okay? Okay, new guy right here. We've got a domain. There's no square roots, so all we got to worry about is this x. So our domain is x can't be 0. All right. We want to write the function in lowest terms. Our numerator is a difference of two squares, so we can write it as x plus 1, x minus 1, and divide that by x, which is already in lowest terms. But we can't simplify anything, so we're done. All right. Then we want to find the intercepts of the graph. So I'm going to take x plus 1 and x minus 1 as our numerator that's already been factored and set those equal to 0. So x ends up equaling 1 or negative 1. So we will be crossing the graph at both of those places because the multiplicity for both is 1. Alright? So we found the intercepts. You can ignore this, sorry, that should have been removed. But because we already found that before. So now we want to test for symmetry. So we want to say, alright, well f of negative x, and in our case that was negative x squared minus 1 over negative x. So that ends up with x squared minus 1 over negative x. So this is not negative f of x, and it is not f of x, so it's a neither. So it won't have symmetry. Alright, so now we need to find the vertical asymptotes by finding the zeros of the denominator. Well, that only happens at x equals 0. So we're going to have one vertical asymptote there. Alright. And then last but not least, we want to find our horizontal asymptotes. Our horizontal asymptotes are going to be, let's see, we're going to have to do some long division because our numerator has a larger power than our denominator. So m equaled 2 and n equaled 1. So x goes into x squared, x times, and then x times x is x squared. Subtract. So I end up with 0. And we've got a 0x and we got a minus 1, which can't divide. So my answer in the end is x minus 1 over x. And so my oblique asymptote will actually be y equals x. So I know that my oblique asymptote's y equals x, which is a linear function going through 0, 0, having a slope of 1. So I put that asymptote in. I also know that I have a vertical asymptote at x equals 0. In fact, I'll do this in red. A vertical asymptote at x equals 0. And then we had y equals x here. And I'll go over that kind of in red there to make it obvious. Alright, so next thing I need to do is pick some values on either side. So I'm going to plug in values once I plug this into my calculator. So I've got y equals parentheses x squared minus 1 divided by x. And graph. Second table. Let's start at negative 5 again. Negative 5, negative 4, negative 3, negative 2, negative 1. 0 is going to be an error. 1, 2, 3, 4, 5. So at negative 5, we're at negative 4.8. At negative 4, we're at negative 3.75. Negative 3 is negative 2.67. Negative 2 is negative 1.5. And negative 1 is 0. Alright. Then we knew that 1 was also a 0. 2 was 1.5. 3 was 2.67. 4 was 3.75. And 5 was 4.8. So our graph, if we go out to negative 5, down to negative 4.8, so our graph is really coming right along here and just shooting on up. Alright. The only problem is that we need to make sure we have our intercepts right. So negative 1, 0, 1, 0, and again we come down along here just like that. Come along here and shoot on up. Alright, so you plot your points and then it looks just like that. Generally your asymptotes help guide the way. Okay. Alright. Okay, so here we've got a function. The domain of the function is going to be when x squared plus x minus 12 is set equal to 0. So x squared plus x is 12 equal to 0. So x plus 4, x minus 3 equal to 0. So then x can't equal negative 4 or 3 for a domain. Our function in lowest terms, the numerator factored completely would be 3x times x minus 1. And down below we had x plus 4, x minus 3. Alright, so there's our function in lowest terms. And then the intercepts of the graph are going to be when our numerator is 0 for x. So we get 3x times x minus 1 equal to 0. 3x equals 0, so x equals 0 is a 0. And then x minus 1 equal to 0, so x equals 1 are the x-intercepts. Our y-intercept is going to be when you plug in 0 for x. But if you plug in 0 for x in the numerator, you end up with 0. So 0, 0 will be our denominator, our y-intercept. Alright, so we want to test for symmetry. So we've got f of negative x. F of negative x equal to 3 times negative x squared minus 3 times negative x over negative x squared. So we have negative x squared there plus a negative x minus 12. So we get 3x squared plus 3x over x squared minus x minus 12. So not everything changed on this, so we're going to say neither one more time. Alright, so then we want to find the vertical asymptotes by finding the zeros of the denominator. And we already did that up above. We said x equals negative 4 and x equals 3. And in case you forgot, we got x squared plus x minus 12. That factors to x plus 4, x minus 3. So then x equals negative 4 and x equals 3 would be your vertical asymptotes. Again, that's where your denominator is equal to 0. Horizontal asymptotes come from our function. We had this 3x squared minus 3x over x squared plus x minus 12. So the powers are the same. So then we look at the coefficients. So our coefficients are 3 and 1. So then y equals 3 will be a horizontal asymptote. So I'm going to plot that. Y equals 3. Plot our other asymptotes. We got x is negative 4 and 3. X equals 3. Okay. So then we go to our calculator. Okay, so I've entered this into my calculator, and okay, so we want to create an XY chart. We want to pick some numbers to the left of negative 4, so we go negative 6, negative 5. We could pick to the right of negative 4 and in between here. So we get negative 3, negative 2, negative 1, 0, 1, 2, 4. So what we end up here with is our table on the left. Negative 6 is at 7, so I plot that point. We're at negative 4, negative 5, negative 6. So there we go. Okay. Negative 5 is 11.25, so we're off the charts, actually. 0 is 0. We already found that from earlier. Let's let's see, -4, we have an error. -3, we're at -6. So right there. -2, we're at -6, not +6. 4, 5, 6. So we're down here. And then -2, we're at -1.8. So we're just above -2 there. -1, we're at -0.5. And then at 1, we're at 0. And at 2, we're at -1. So our middle kind of gives us this picture here. Alright, and our left side looks to kind of shoot up like that. Sorry for the little wobble. And then outside of 3 here, at 4, we're at 4.5. At 5, we're at 3.33. And we've got this all listed. So I would list all these just like that. So our graph should look something like this. Okay? And you'd fill in your chart here. -4, or so at +4, we were at 3.3, or 4.5. Let me try that again. 4, we're at 4.5. 2, we were at -1. 1, we were at 0. 0. -1.5. Oh, -0.5, sorry. -1.8. And -6. And -5, we're at 11.25. So there's my table, there's my graph. Okay, so we want to analyze this graph first and then graph it. Domain is going to be where the denominator is 0. So again, x squared minus 4 equals 0. So x squared equals 4. So then x equals plus or minus 2. So then x can't equal plus or minus 2. Write the function in lowest terms. So I need to factor both the numerator and the denominator. The denominator is a difference of 2 squares, so we get x plus 2, x minus 2. And our numerator is going to factor to, let's see, 2 times 2 is 4. And we need that to add to -5. So we got 1 and 4, 2 and 2. So it's going to be -1, -4. So we get 2x minus 4 and 2x minus 1. So then we end up with x minus 2 times 2x minus 1, because this guy right here can simplify. When I write in my 2x and my 2x from 2x squared, I'm artificially adding in a second 2, and so I need to simplify that out as best I can. Alright, so now here are our factors. So then I can write it like that, x minus 2 and 2x minus 1. Alright, so we have the function written in lowest terms. Something important here is that this factor and this factor will cancel out, leaving 2x minus 1 over x plus 2. Here's something interesting. Because that happens, at x equals 2, we're only going to have a whole. We're not going to have an asymptote any longer. So we'll see that come up pretty soon here. Okay. Let's find the intercepts of the graph. The x-intercepts come from the numerator, so we get. But we need to realize that this is our new function now. So our only numerator that we can get a 0 from is the new one. So we set 2x minus 1 equals 0, so 2x equals 1, and x equals 1/2 becomes our only 0 of the function. Okay. And then our y-intercept, again, we plug in 0 for x, and end up with negative a half. So our y-intercept would be 0, negative 1/2. So we want to test for symmetry. We got 2 times x negative minus 1 over negative x plus 2. So we end up with negative 2x minus 1 over negative x plus 2. The whole thing didn't change, so again, it's neither. Alright. So then we want to find our vertical asymptotes. Again, we did that by saying that our zeros of our denominator are at x equals negative 2, because x plus 2 was all that was left on the bottom after we divided away all our factors. Okay, so our vertical asymptote's there. Okay, so we want to find our horizontal asymptote. We have 2x minus 1 over x plus 2, m then equals n, because the power of x is 1 and 1. So then y equals 2 over 1 is my horizontal asymptote. So in red I plug that in. We also found our vertical asymptote earlier at x equals a half. And then something worth noting is that there's going to be a hole at x equals 2, because we had that x minus 2 that used to exist but canceled out. That creates a hole, or an undefined value at x equals 2, just not an asymptote. Okay. Then I plug this into my calculator and I create my XY chart at negative 3, negative 2, negative 1, 0, 1, 2, 3. Again, we have an error at negative 2 and 2. We have at negative 3 we're at 7, at negative 1 we're at negative 3, at 0 we're at negative 0.5, at 1 we're at 0.33, and at 3 we're at 1. Okay, so I'm going to plot these. Negative 3 we're at 1, 2, 3, 7. Negative 1, negative 3, 0, negative 0.5, 1, 0.33, and 2, we have an error. Okay, so what we do here is we say, alright, what is 2 times 2 minus 1 over 2 plus 2? So this is what is left over after we've divided away the factor in the denominator that made a hole at 2. So we're finding out where we're approaching. So 4 minus 1 is 3 over 4. So we have a hole at 2 comma 3/4. And the way we show that is just a little open circle there. So that's where we're approaching to. As x approaches 2, our f of x approaches 3/4. But because of the initial factor of x minus 2 over here that canceled away earlier when we had our factors like this, it's still a point of what we call discontinuity. Discontinuity. Alright? And so our graph is still going to come up, it's still going to get really, really close to that point, and then continue past it as if nothing happened. But there's a hole, a point of discontinuity there. And then our left side looks kind of like this. Alright? Alright. So, again, we found our first error was our vertical asymptote. But our second error was a hole. So in order to find where that hole is exactly, you plug this into your simplified guy, your 2x minus 1 over x plus 2, where it's written in simplest terms. you'll be able to get a value out, but there won't actually be a point there. It's telling you where the point of discontinuity is from the original function. Okay? Alright, so now we want to write a function from its graph. And the first thing I want to try and find is p of x. P of x will be our numerator. Okay? And our numerator starts by looking at its zeros. So we touch the x-axis there at -2, 0. That means that x plus 2 is going to happen twice. But we cross over here at 5, 0. So that means that x minus 5 happens once. Could possibly be 3 times, but I go with the simplest version. Okay? Okay, and now we need to figure out what q of x is going to equal. So we have to, in order to do that, we got to look at our vertical asymptotes, because it'll be p of x over q of x. And our vertical asymptotes are x equals -5 and x equals -5 and x equals 2. So then we'll have factors of x plus 5 and x minus 2. So then the question is, well, I have a horizontal asymptote. So what that's telling me is that when I write this function, I've got to have x plus 2 squared and x minus 5 on top, and the power of that is 3. So the power on the bottom has to be 3 as well, because if I have a horizontal asymptote at somewhere other than y equals 0, then they had to be the same power. And right now I've only got x plus 5 and x minus 2 on the bottom. So one of these is going to have to be squared. And so the question is, which one? Well, we look at the way that our f of x, where it approaches from the left and from the right. You can see here, as we approach -5 from the right, we shoot down to -infinity. And as we approach -5, we shoot up to positive infinity. So when they're opposites like that, we say that they're odd multiplicity. Okay? An odd multiplicity. Whereas x equals 2, whether we're approaching 2 from the right or 2 from the left, we're shooting to -infinity. So we would say that that has an even multiplicity. So that gives x minus 2 our squared. So now we have a power of 3 on the bottom and the top, which is great, except our horizontal asymptotes y equals 2. So we need a coefficient of 2 on top. So my ultimate function then is f of x equals 2 times x plus 2 quantity squared times x minus 5 all over x plus 5 times x minus 2 quantity squared. There's my function. And if you enter this into your calculator and graph it, you'll get the exact same thing. Hope all that helped.